Hello! Last year at the Amiga Kickstart event in Nottingham in the UK, I built and took along my floppy disk backup station. This time, I'm hoping to also take along a disk cleaning station too, which should aid in the recovery of disks that are mouldy. I've no idea if this is even going to work, so let's get designing. The first thing I'm going to do is design what I want. My plan is to have some kind of tray that the floppy disk can sit in, which is moved along using some kind of conveyor belt to an area where the disk surface can be cleaned. After this, the disk needs to be dried, so it would hopefully move along to a second stage, which would maybe have some fans and a heater to gently evaporate any moisture. Now I was thinking of maybe a third stage that goes straight into a floppy drive, but I think that might be a little bit too much. Now, me being me, I want this thing to look a little bit crazy and maybe a little over the top too. So I'm going to jump over to Tinkercad and start playing around. So firstly, and probably the most important thing I need to do is to hold the floppy disk. So I built this. Nothing very exciting, but it has a notch to keep the shutter open. It also has a lowered section that could allow the inside of a disk to be placed too. On its own, this isn't much use, as we'll need to also be able to rotate the disk. So I've designed this little piece that can hopefully attach to a motor and clip to the underside to turn the disk. Now the motor I'm planning on using is one of these stepper motors. They're not very fast, but they're also very easy to control with the Arduino, and given they're also geared, they're surprisingly strong. Now I find the best way to design 3D printed parts is to model all of the other parts that attach to them, which allows me to see where it could fit on the disc holder. Now it occurred to me that placing a disc here could be a little bit of a pain. The bit inside the floppy drive that rotates the disc usually has a springy outer pin, so that as the motor spins, the disc eventually aligns and clicks into place. I'm going to need to be able to do that too. So, this is the new design for the centerpiece. The idea is that the little plunger could fit inside with a suitable little spring, and then when all glued together should give the desired springy result. Now the best thing about 3D printing stuff is you can just print it again if the design doesn't work. Anyway, I printed this part out, so let's have a look at assembling it. Seems to work quite well, and it should fit on top of the motor too. Now you may have noticed in that clip that I made a second one earlier, always good to have a spare, and I made sure to allow plenty of time for the glue to set, and it seems to be pretty perfect. Next up, I want the disc holder to slide into the various sections, so I need some kind of track, and from owning a 3D printer I've seen all sorts of ways of doing this, and then I found this linear rail and bearings kit, and about the sort of length that I need too. I've always wanted to have a play with these, which means I need to update my disc holder design to allow it to run along these rails. Once again I've modelled these as you can see. Now you might also spot this raised area at the bottom. Well, I'm planning on pulling all of this around using a timing chain, and to attach it using one of these clamps. And this section is where I intend on attaching all of that. I also need to design something to hold the rails, and something for the timing belt to run on, so that's what I've done here. You can also see I've added a motor to the bottom to pull this all around. Now I don't know if the angle it's at will be able to grip the timing belt properly, so I may have to do a mod for that later. The red blob on the left is where I plan to put some kind of switch so I can detect when the disc is at the end of the track and stop, which will also be used during a reset cycle to work out exactly where the disc is. Well, that's the plan at least. My theory is designing everything like this should reduce the number of mistakes and reprints needed. Now you may be wondering why I've mounted the disc tray vertically. Well, I figure at some point I'm going to need to get something like isopropyl alcohol onto the cleaning surface. And I don't know what that cleaning surface is yet, so gravity might be quite useful here, but we'll look at that later. Right now we have another problem. If I leave this like this, then the disc will probably just fall out, so we need some kind of clamp to hold it. And my plan is something like this. And if the two ends are screwed down a little, then the thin piece could act a little bit like a spring when attached to the plunger, holding the disc in place. So I'm going to print both the disc holder and this clamp and put it all together to see if this will work. next problem I need to solve is how to actually clean the disc surface. I had a thought about how automated car wash systems work, and it got me thinking about a little silly idea. I found these and I ordered them, designed to work with a Dremel, but bits come off them far too easily, and then I stumbled across these, and these may just be perfect. They need to be attached to some motors, and luckily you can also get these things called shaft couplers that will fit the motor one end and these the other. Excellent, but for these to actually make contact with the disc, there'll need to be a way for them to move so they don't get in the way of the tracks. So, I plan to use a pair of servos to move the cleaning heads to the right position during the cleaning operation, as well as move them out the way when the drive's moving. Servos are great, you literally just tell them what angle to move to and they do it, and hold that position too. And this is how I plan to place them along the track each side of the disc. Now you may notice some switches under the servos. They're not strictly necessary, these servos don't need any kind of home position calibration, but just in case I've added them here. So the plan is I'll have those motors spin those buffing rods around whilst moving the floppy drive back and forth. Every time it moves, I'll advance the disc motor slightly to move the disc surface. Now I'm planning on dripping isopropanol onto these wheels, but that's a task for later. After the disc has been sufficiently cleaned, they'll be needed to move to an area where they can dry out, so the last stage is to make some kind of heater fan. For fans, I'm planning on using these to blow air at the disc surface as the motor spins it. Now I'd like to heat this a little too, and my first thought is just to use a low value, high wattage resistor in the middle of the airflow, and I plan to mount them like this. So I guess I'll print these and test them out. Things don't always go quite to plan, and whilst they look okay, after testing them, I found that even when the resistor was stupidly hot, it wasn't heating up the air, probably because they didn't have enough surface area, so I've decided I'll try something different, and I found these flat PTC heaters, meaning they reach a fixed temperature so there's no chance of this overheating, and if I stick heat sinks like these to either side of it, it'll probably work a lot better. So, I'll have to adjust the print slightly because these are slightly bigger, and with all that done and when it's printed, I'll have another go at assembling them. That's much better. And they only get slightly warm, but I do feel it's a bit safer, and besides I don't want to melt the floppy disk. Now the only problem at this point is the entire thing is longer than the size of my 3D printer, so I'll need to print the base in separate parts and glue it all together. To make sure I glue everything in the right place, I've created raised areas in the base, and this base can be printed in 3 parts. I'm also going to want some controls for this too, so I've added a raised area where these can go. As I said earlier, I'm going to need some way of dripping isopropanol alcohol onto the disc cleaners. So, I've created an archway that will allow me to run a pipe up there, split in 2 and then the outlets being directly above the cleaners. Well, that's the theory anyway. I may also add a whole bunch of LEDs to this just to make it look really cool. Now I need to print the final pieces and stick them all together. After a long time allowing the glue to dry, and yes, getting the super glue off my fingers too, I added some LEDs to the base. I also created 2 PCBs to hold the 2 Arduinos, one to control all of the motors and the others to control everything else. And I added some LEDs to the base too. These are individually addressable LEDs, so I should be able to have some fun with those later. I've also ran all of the wires to the underside. But I couldn't resist and tried out the timing chain, and I found that it couldn't grip the motor at all. So I designed a small retrofit that contains 2 extra wheels to force the timing chain to move around more of the motor wheel. This should grip much better, and to help I've got a timing chain tensioning spring to add too. Once printed, I glued it all into place, so let's have a go at assembling the rails and putting it all together. Yeah, that was such a mess. Attaching that tensioning spring snapped the motor off the base. I need to glue it all back together again, and this time I'm going to pour so much glue on it. Also, I don't think the tensioning spring is actually a very good idea. After all, it doesn't really need to be that tight, just enough to properly catch the motor. I think I could do that in a much easier way. So I'm going to glue it all down, and I mean really glue it all down, and reassemble the disc section. And I'm also going to add a pipe that will drop the isopropanol alcohol onto the cleaning heads. Now some of you may have noticed an SD card under there and a headphone socket. Well, this thing's gonna make some noise, so I need some speakers. this has got to be one of the most craziest looking contraptions in the world, so at least I've achieved my goal and possibly created an over-engineered, silly looking device that might actually clean a floppy disk. But this isn't going to work without writing some code for the Arduinos. And there's a few other surprises I want to throw in too. Plus, you haven't seen anything to do with pumping the isopropanol liquid either, lots still to do. Now if you want to see this working, then you have two options. The first, I'll be taking this back to the Kickstart event in Nottingham in the UK at the end of the month. Well, assuming it works anyway. But for those of you who can't make that, you'll have to wait until my next video. So, until then, make sure you subscribe so you don't miss it. Thanks for watching, and I'll see you in the next one.